Okay, so for lenses, I'm going to do lens ray diagrams. Now, this is a converging lens because it focuses all the light at a focal point. Okay. Remember that this is our optic center. Okay, anything that passes through that does not get refracted. This line here in the middle of my lens, okay, is the axis of symmetry. Okay, normally a lens would refract as the light enters and then again when it leaves, but we're going to not do both refractions, and we're just going to do the refraction from the axis of symmetry, okay, because that's what it would be equivalent to. Now, kind of like with curved mirrors, okay, my first ray, I start at the top, I go straight, from there it passes through F. Okay. My second line, I will pass. Oh, I don't like where that started. I'm going to pass through F. Okay. So we hit the line, and then come straight. Okay, and don't know where that one came from. We're going to get rid of it. And we're going to do our third line as a check, which is the line that passes through the optic center. And fortunately it passes right through all those points. So our image is right here. Okay. Now, the light where everything either comes to a focus or appears to come focused from is denoted as F and 2F, and the other side, the focal points are primed. Okay, so everything looks like it comes to a focus on this side of the lens. Okay, so these are the 2F prime and F prime. So if we were to do lost for this image, now remember for lenses, the real image is where light passes through. Same thing with mirrors, except for mirrors, it's reflecting light, so it's on the same side as the object, okay, in front of the mirror. For lenses, it's behind the mirror, okay? Sorry, behind the lens. If you're vigilant about your F primes and 2F primes, then you can just say between F and 2F, and I will know that you mean behind the lens, okay, for a converging lens. Its orientation is inverted. Its size is diminished. And the type is real. Okay. Let's go to our next image, and again we're going to place our object, except we're going to place it at exactly 2F. Okay, so we're going to draw the same lines again, from there, and it comes through F. If I go through F, it'll come out parallel. And okay, and the last line is through the geometric, or the optic center, and our, it's right at 2F. Okay. At least it should be. My drawing's a little bit off. Okay. So lost. Okay. Location is at 2F. Okay. And again, these are the primes. Okay. Its orientation is inverted. Size is the same, and type is real. Okay. It's kind of like when the object was at C for a mirror. Okay. And let's try and get one more in. And we're going to place this guy between F and 2F. Okay. Let's try and put them straight though. Alright. And same thing, parallel to the principal axis, passes through F, and it will refract parallel, okay. And then if you go through the optic center, there. Sorry, I think I stopped recording there for a second. But here we are, and we're going to do lost. Location is beyond 2F. Remember that these guys are the primes. Our orientation is inverted. Size is enlarged, and type is real. I think I'm going to stop here. Alright, so now we're going to look at an object that is at F. Oops. It's a little crooked, just going to straighten that out. Okay. So start off with the same line, parallel, principal axes. It goes through F. Okay. And then we can't go through F this time, so we're going to go straight through the optic center. And those lines should be parallel. Okay. So because they are parallel, no image is formed. These two lines will never ever meet because they are parallel, and so there's no image formed. Okay. So that takes us, before we finish, I should remind you, those are the primes. We're going to go to the next page before I get started. Just label those as prime. Okay, this one is going to be a little bit harder for me to draw. And it's going to be in front of F. Okay? So we're going to do our object here. Okay. And just as before, I'm going to come in, it's parallel, it's going to refract through F, okay. And then again we can't go through F, So we're going to go through the optic center. Okay. And these lines, you can tell, are getting further and further away from each other. However, they do look like, I'm going to draw it here. Okay. Oops. So it looks like they meet here. Okay. It looks like they're coming from left side. So I'm just going to label this so you know that's the object, that's the image. And if we were to do lost for this, so the location of the mirror of the image is in front. Oops. It's in front of lens. Before F. Okay. Its orientation is upright. Its size, it's enlarged. And the type of image is real. Sorry, virtual. Okay. And we know that because light rays don't actually pass through it. It just looks like light rays do. And you can tell because we've used the dotted lines, and those dotted lines are to extend the refracted lines. Just like with mirrors, we extended reflected lines with refraction and lenses, we're going to extend the refracted lines. Okay? Now, this is actually what magnifying glasses do. When you're very close to the lens, that's when it enlarges the image. When you're far away from the lens, and if you have a magnifying glass, you can check this, it actually flips the image upside down. Okay?